Hey everyone, welcome to Philip in the Cloud. Today I'm going to be talking about performance between DuckDB and Pandas. So let's get started. First we're going to do some imports and we're going to pull from IBIS examples. And if you haven't seen examples yet, we have ibis.examples, that's a module, and then the interactive import actually loaded that up as EX. So we have like access to all of our examples here. Let's pull up IMDb name basics, which is a table that contains all of the kind of named entities of people of various jobs and uh, uh, careers kind of in the the movie industry. So we're just going to call that T for now. And you call fetch to pull down an example. In this case, I've already pulled down the data, so it didn't have to fetch anything from cloud storage. But if you hadn't fetched it, it would be automatically fetched for you, so it gets cached on disk automatically. That's a neat library. We're doing that with a library named Pooch. It's a very neat library. Check it out. And let's look at our table. All right, we've got something called nconst, which is a, oops, sorry about that, which is an identifier. It looks like a unique identifier for the row, and then there's the primary name of the person, birth year, death year, a comma-separated list of their professions, and then what look to be some identifiers for the titles that they're known for. And if you look at some of the IMDb examples we've got a bunch of title tables here. So AKA is what they're also known as, basic information, what crew was on the title a particular movie at the time or TV show, episodes, principal people involved, and then a bunch of ratings from other people. We're only going to look at name here. Because we're going to kind of do a bit of a data cleaning task here. So the first thing you might want to do is maybe turn some of these things, into numbers. So for nconst, like that's pretty easy, right? We can say t dot mutate, nconst underscore nconst replace. We want to remove nm, replace that with an empty string, and then we're going to cast that to an integer. Oops. I'm going to close parentheses. That was instantaneous. IBIS knows how to sort of make, kind of convert the types here. It's just inferring that, okay, we know replace is taking a string and returning another string, and then cast is returning an integer. So cool. Now we've got nconst. We've got integers. We can do things like t.nconst, t.nconst.nunique, which will show us the number of unique values. Okay, and then we can look at the count. And we'll be, okay, so we know that nconst is a unique identifier for the table because the number of unique values in that column is equal to the number of rows in the table. These are actually stored on disk in Parquet format, but that's sort of hidden behind the examples module. In IBIS, the examples modules data can be CSV or Parquet. So let's look at that table again. Okay, the next thing you might want to do is let's turn primary profession into an array of strings. And we're going to make the assumption that they are separated by comma. We'll rename it in place with mutate, primary profession, underscore, primary profession. And just like, string split to list in Python, you can call the split method on an array, on a string column. Looks like I made a mistake in typing. This should be primary profession. Cool. Let's look at that again. Okay, now we've got this big kind of array table here. Let's just start looking at the head of the table. At least we've got the columns there up next to my face. And what's sort of happening here is the printing, IBIS's printing mechanism is detecting that our terminal width is like it's like somewhat narrow because I've got the font size jacked up. And so Rich is kind of wrapping the lists here into giving it new lines and so forth. All right, but we've got our array of strings. So now if we wanted to, and we'll do this later, we're going to unnest that. But we've still got one more thing that we maybe want to do, which is convert known for titles into a list of integers, which is sort of going to combine the two previous steps. We're going to take our list of strings, we're going to split on comma, and then we're not going to unnest and then cast everything to a string to an integer. We're actually just going to apply a function to every element in the array for every row. And I've got a separate video. I'll put a link in the description that describes that sort of goes through some of this sort of array, custom array kind of functions, basically like applying sort of lambdas to each element of an array rather than having to unnest and regroup and so forth. And it's really complicated without sort of that functionality. So check that out. I'll put a link in the description. All right. So we've got t. We've casted nconst into an integer, and we've split the array of strings from primary profession. And now we're going to do another mutate, and we're going to say known for titles. And hopefully I can get this right so we don't get a weird error message. Known for titles dot split, where again we're going to split on commas. But instead of stopping there, we're going to say dot map. And we are going to pass a lambda. And let's just call this tconst. And we're going to say tconst dot. We're going to do the same thing we did with nconst. Replace tt, except we're going to use tt instead of nm. We're going to replace that with an empty string, and then we're going to cast, not cat, to an integer. And the thing to note here is that this is all being compiled in the SQL. Like Ibis is not taking a lambda function and then like calling it for you on these 12 or so million rows. That would be very inefficient. But we actually can turn that lambda into a SQL lambda for the engine that we're using, which in this case is DuckDB. Cool. Got some nice formatting for my Python. So let's take a look at that now. Let's do head again. Let's just look at the first two rows. Cool. We've got, again, nconst casted, primary name, birth year, death year, all the same. Primary profession is array of strings that we split. And now we've got known for titles, which is like a nice list of integers. So let's actually, but what if we wanted to sort of, just count up the number of, we just wanted to get sort of like a top K of primary profession, or even just do a group by count on primary profession, like how many soundtracks, actors, etc., sort of primary profession counts are there? Like what, you could answer questions like, what's the most common primary profession? Maybe it changes by year. That's like another analysis you could do. But to do that, we need to actually like sort of do this unnest operation here. And let's actually sort of like, let's unnest. Let's first do, let's just reassign primary profession to an unnested table. So again, we've got primary profession. IPython's helping me out here. And we're going to do primary profession. Now remember, primary profession is now an array. It's no longer a string. So it's got a different set of methods. So we're going to call unnest. And this is going to take each element out of that array and replicate all the existing rows, for once for each element of the array. And again, it's fast because Ibis knows that all we're doing is saying, hey, turn this thing from an array of string into a string. So computing that schema is pretty cheap. And then when we go to actually like look at it, there's a little bit of latency involved. Not too much because DuckDB is fast, but we see that, okay, we've actually got, soundtrack actor, first two elements of that, of the what was previously one row. So nconst is no longer a unique identifier because you can see nconst is Fred Astaire. Nconst 1 is Fred Astaire. So now we've got two rows for that. But now we can actually compute, say, the number of soundtrack, the number of primary professions total and see what the most common is. So let's do that. So we would say t dot group by primary profession, we would say count. Let's just assign that to prof. Again, it's instant to compute the schema. We know that count is an integer aggregation. Primary profession is a group, as a string, and so we've got two columns in that in that output table. So this might actually take a bit of time to compute. Not too bad. DuckDB is pretty fast. We've got some funky things. It looks like there's a bunch of nulls here. So art department, music department, camera department, sound department, etc. We could also do something like t dot top k primary profession. T dot primary profession dot top k 5, which will sort of do this group by count and then sort, and then give me the top 5 for that. That's also going to be pretty fast. Looks like the top 5 are actor, null, actress, miscellaneous, not super useful, and producer, which is, these are all not super surprising. Let's filter out those nulls. T dot primary profession. The way you do this in IBIS is you can say not null. You can also say like tilde, underscore dot primary profession dot is null. But this can kind of keep you in kind of the method chaining flow if you want to break out to kind of go to the beginning of the expression, add a tilde, and so forth. So let's do that. That'll filter out the nulls. Sorry, tilde is not null; it is empty string. So we actually need to check for empty string. So in that case, we actually do want to say length greater than 0. Let's look at that. Okay, now we've got something more useful: actor, actress, miscellaneous, producer, writer. Let's remove miscellaneous since that's not super helpful. We're going to need to wrap this due to Python's operator precedence with the ampersand operator. And we're going to say dot primary profession not equal to, I'm just going to copy in miscellaneous because don't really feel like misspelling that. And we're just going to call this, let's just call it top here. All right, so these seem relatively sane. Top K, actor, actress, producer, writer, camera department. Cool. So we've got something useful. Now let's sort of let's see if we can kind of replicate this in Pandas. Well, first off, yeah, let's see if we can replicate this in Pandas. So the first thing I'm going to do, I'm going to give Pandas up front. I'm going to give it all the sort of like unnesting and all this stuff, right? I'm basically going to just take this t. I'm going to say df equals, t dot execute, which is going to bring the whole thing into memory as a Pandas data frame. And I'm going to try to replicate this like filter expression and top k computation here. So this actually takes a little bit of time because the table is relatively big. Originally we had 12 million rows, I think. And that it's expanded because we did the unnest. But I want to give Pandas a fair chance here. And by the way, Pandas might be okay for your use case. If you're sort of at the limit though, where like you have a terabyte on disk, that's plenty of, and you've got plenty of disk space, but you need some more RAM because you don't have a terabyte of RAM on your laptop. Then looking into IBIS and DuckDB together might be the thing that would help you out. Wow, this is taking a very long time, which is not great, but hopefully we can actually get something out of this. Let's see if we can do it. I'm running on a machine that's got 64 gigs of RAM and about 32 cores. So I think I should be able to fit this in memory, but I guess we'll see. Hopefully I don't hit an out of memory error in the middle of a live stream. That would not be great. All right, well, in the meantime, let's actually see if we can see what's happening. Okay, I just opened up a new pane in Teammate. I'm going to look at btop. It looks like there's not much CPU happening, but I'm not using too much memory either, so that's interesting. Terminal size too small, sure, okay. it looks like maybe this is just maybe a slow path in DuckDB. I mean, OBS Studio is using up a bit of stuff, but not too bad. Okay, it completed. Let's close this out. Let's look at df head. Cool. We've got all the things that we had before. It looks like our birth and death year have been converted to floats because nulls. And let's look at our previous computation. So we filtered out empty strings, and then we also filtered out miscellaneous, and then we did a top K on that. So first we're going to do df.primary profession .stir.len, I believe. Let's just see if that actually does what I want. Len. Okay. It looks like that's sort of slow. So we're going to do df of this stir.len greater than 0. And then we're going to do df, what did I say? Not equal to miscellaneous. Okay, let's just copy that again. Miscellaneous df dot primary profession not equal to miscellaneous. We're going to filter that. Let's say df2. These are terrible variable names, so I guess downvote the live stream if you hate that. This is probably going to take a while. Hopefully not too bad. Okay, not too bad. Cool. So we've got df2. We've got filtered out stuff. And then we're going to do a group by on primary profession. Well, actually, let's just see if there's like a top K method here. Profession dot top K. Top anything. Okay, tab completion is taking a while. So like a bottom something? Nope. Okay. All right, so let's just do it kind of the dumb way. Do a group by count. Group by primary profession. And then we'll do a dot count. And then we'll do a sort values on count. And we want it to be descending, so we'll say false, because ascending is true. And hopefully I haven't abused the data frame API here. Let's actually just get this first so we can not futz around too bad. We're going to do this all in one shot to do the performance comparison here a bit, but I'm just going to make sure I got the correct API calls going here. All right, so let's look at the head of that because that's kind of a big data frame. It looks like it counted every column, and that's not quite what I wanted. I really only want to count, I guess we can just count primary profession, or let's count nconst. Oh, value counts. Thank you, Secret Asian Dan. My pandas knowledge is pretty rusty. df2 dot primary profession, and maybe this will actually negate my original clickbaity title for this video, but maybe not. I don't know. Let's see. All right, that was like pretty fast. So let's see, df3 head. Cool. Okay, this is pretty much what I wanted. It looks like it's more or less sorted already. Maybe value counts does the sort for you. Drop NA equals false. Drop NA equals false. Sure. I don't know if that will change much, but let's see. Doesn't change the top K result. But to be totally right, we'd probably want to say something like that, which would be the top K5 that IBIS gives you. So let's kind of put this all together. The first thing we're going to do is we're actually going to run that. We've already got this top IBIS expression, right? We can sort of do that, wrapper the result, and That actually was pretty fast, right? So let's execute that and time it. We'll be super scientific and use the time it magic for IPython, top.execute. And let's see what happens here. Let's get some numbers, some raw numbers here. This takes a minute. It's gonna kind of loop a bunch of times and look at some central tendency and measures of spread to compare. Okay, cool. So it took about 1.88 seconds, 2 seconds, plus or minus some milliseconds. Now let's put the whole sort of pandas expression back together. So this is our filter. So now we need to add sort of this primary profession value counts drop NA equals false head 5. And that's sort of the whole expression right there. Let's just confirm that this actually does kind of what we want. Let's run it. All right, good. So now what we can do is we can write, again, time it, and IPython will not work exactly because of multi-line editing, so I'm just going to remove all the lines. It's going to be kind of ugly, but let's see what happens. So remember, we've got 1.88 seconds for DuckDB, plus or minus some milliseconds. And let's see how Pandas does here. Yeah, I could use %%, but well, actually, it probably would have been less typing. Yeah, okay, fine. Fine. And %% time will do the time once, which it's probably enough for a live stream. On the other hand, okay, so this doesn't quite have the speed up that I was tinkering with earlier today, but I also changed the problem at the last minute, so sue me. So we've got pandas, and we've got that at 5.3 seconds. And then we've got DuckDB, which is at 1.88 seconds. We've got pandas divided by DuckDB. So pandas is about 2.8 times slower in this particular instance. We can potentially watch the memory usage, although it might be a bit tricky because my terminal is humongous. But let's see if we can look at the memory usage. Okay, btop is not a fan. Let's see if we can make it wide enough. Okay, well that's kind of gross on the left, but let's try it anyway. Wow, that's terrifying. That's a great conclusion there. 2.8 ducks per panda. So let's see if we can see any kind of memory use difference here. We've got our total. Let's see, what do we've got? Our currently using about 10 gigs of RAM. Let's see if running this changes peak memory at all, or anything like super obvious. All right, didn't really do much to the RAM. It looked like CPU went up a little bit, but that's because Pandas is going to use a core. If we run top.execute, then we'll probably see the cores go up, at least we should, and memory usage hopefully won't get huge. We saturated our cores pretty quickly, and I didn't really actually catch the memory change. Looks like no obvious memory change. I mean, there's all sorts of wacky stuff here, like the terminal is huge, so maybe there's a decimal point that we can't see, and yeah. Anyway, 2.8 ducks per panda. Your mileage may vary. Oftentimes, DuckDB is much faster for more or less the same level of kind of API efficacy. You can interact with the thing. You can operate on data that just like pandas will not be able to handle. So, thanks for tuning in, everyone. Hope you enjoyed the live stream, and I will see you next time.